Hello friends, today we are going to continue with our topic of laws of motion. So we are going to start with from where we left, that is acceleration. We have defined acceleration as change in velocity with respect to time. Now today we are going to cover following topics. We have already covered uniform motion, so we are going to again reiterate it. Then we are going to cover non-uniform motion. Thirdly, we are going to cover velocity time graph. For constant velocity. Then we are going to cover velocity time graph for uniform acceleration. And finally, we are going to cover Newton's equations of motion. There are three equations of motion given by Newton. V is equal to U plus AT. S is equal to UT plus half AT square. And V square is equal to U square plus 2AS. So this is how we are going to cover today's session. So we are going to start with uniform motion. If you look at this table, suppose Anuj is a guy who travels a distance by car. He covers in every 10 seconds 15 meters. So at time equal to 0, he is at 0 distance. At time equal to 10 seconds, he has covered 15 meters. At time t equal to 20 seconds, he has covered 30 meters. That is another 15 meters. At time t is equal to 30, he has covered 45 meters. And at time t equal to 40, yes, 60 meters. So the distance is changing by every 15 meters when time increases by 10 seconds. So this graph which we have plotted here with respect to distance and time is a straight line. For every 10 seconds change in time, there is 15 meters change in distance. So this, if we plot on a Excel or on a graphical sheet, we get this straight line. This is called uniform motion. When an object covers equal distances in equal intervals of time, it is moving with uniform motion. Now, if we closely look at this particular graph, here Anuj is covering unequal distances in equal intervals of time. For example, at 5 seconds, he is at 7 meters. At 10 seconds, he is at 12 meters. At 15 seconds, he has covered 20 meters. So, it's not, the distance is not uniform. Maybe there is a lot of traffic, so he's stopping and then moving ahead, decreasing the speed and then moving ahead, then increasing the speed. So, distance covered is uneven. So, if we plot a graph between distance and time for Anuj, we see that for every 5 seconds that he is traveling, the distance is non-uniform, that is 7, 12, 20, 30. So, the graph is not a straight line, but it is a curved line. So, this is non-uniform motion. So, when you cover unequal distances in equal intervals of time, this is called non-uniform motion. This we discussed in the last class as well. Now, let's come to our next topic, which is constant velocity. So, if we see, Anuj is moving with a constant speed of 60 km per hour and time is increasing by 10 hours. This is like Anuj is moving in a train which is moving at a speed of 60 km per hour, or in a car which is moving at a speed of 60 km per hour. And for every 10 hours increase in time, his velocity remains the same, that is 60 km per hour. If you closely see this graph, at 10 hours he is at 60 km per hour, at 20 he is at 60 km per hour, at 30 hours he is at 60 km per hour, at 50 hours he is at 60 km per hour. So, the velocity is constant. So, if we plot a graph between velocity and time, we see that velocity is constant, that is 60 at every 10 hours. This is uniform velocity or constant velocity. Now, can you tell me now I am trying to draw a graph here to explain you further. Now, this is velocity. And this is time. Now, we saw Anuj is moving at a constant speed of 60 km per hour with every 10 hours increase in time. This is 60 and this is time every 10 hours. Now, if I tell you this is 10, this is 20, this is 30, this is 40, this is 50, this is 60, 70 and so on. If I tell you, find out the distance covered by Anuj between 30 to 50 hours. So, how will you calculate this? See, he is traveling with a speed of 60 km per hour. And the time taken is 50 minus 30, which is equal to 20 hours. 50 minus 30. So, what is the distance? Can anybody tell me what is the distance? What will be the distance? We know velocity is equal to displacement upon time. and this is a straight line. So displacement or distance will be equal to velocity into time. Which is 60 into 20. So this will be 1200 kilometer. Now if I tell you, can you give me the area of this particular region? What does this region looks like? It looks like a rectangle or it's a quadrangle. Quadrangle means the one with the 4 angles. Area with a 4 angle. So this quadrangle is actually a rectangle. So area of this quadrangle is how much? Base into height. We know the area of rectangle is length into breadth. So length is how much? This is 60, right? And what is breadth? Time, which is 20. So this comes out to be 1200 kilometer, isn't it? So the area of quadrangle is equal to the distance, which is velocity into time. We found out the distance by this. So if we are given the length and breadth of the rectangle, we can find out the distance covered by an object when the object is moving with a constant velocity. Moving on to next section. If this is distance, and this is time, then this is a uniform speed of the object, the slope of this line. Slope of distance time graph gives us speed. Velocity. It's a straight line, right? Distance is directly proportional to time. So it gives us speed or velocity. So when an object covers equal distances in equal intervals of time, it is moving with uniform velocity. So this slope of this graph, and how will you define the slope of this graph? How will you define? You would have studied this in maths. Slope is equal to, length of slope is equal to y2 minus y1 upon x2 minus x1, which is nothing but change in distance and time taken. So slope of the graph gives us, distance time graphs gives us velocity. Now here you can see that distance and time, they both are directly proportional to each other because the graph is a straight line. On the other hand, if we draw a graph like this, if this is distance and this is time, then the object is covering unequal distances in equal intervals of time. So this is non-uniform motion. So the distance and time are not directly proportional to each other. Distance is not directly proportional to time. We say it like this to put in other words. Distance is not directly proportional to time. Right? So now moving on to our next topic. Uniform acceleration. Now here, what was the acceleration? Can anybody tell me what was the acceleration? The acceleration is 0. Why? Because the object is moving with constant velocity and we have defined acceleration as change in velocity upon time. Final velocity is also 60, initial velocity is also 60 and time taken maybe say 70. So this is 0. So acceleration is 0 here. So when an object moves on with a constant velocity, we say acceleration is 0. Now we are going to define what is uniform acceleration. Suppose an object is moving with a changing velocity which is 8 km per hour at 5 hours, then 16, then 24, then 32. So with every change in 5 hours, the velocity changes by 8 km per hour. So there is a change in velocity, but this change in velocity is constant. So it changes by every 8 km per hour for every 5 hours. So this graph between velocity and time, where we have plotted velocity on y-axis and time on x-axis, we say that for every 5 hours change in time, the velocity changes by 8 km per hour. The change is constant, but velocity is changing. It is increasing with time. So velocity is changing and we know acceleration is defined as change in velocity upon time. So this object is moving with uniform acceleration. So when an object covers moves with constant change in velocity with change in time, we say that the object is moving with uniform acceleration. When there is a constant change in velocity with respect to change in time, we say that the object is moving with uniform acceleration. The object can move with a positive acceleration when the change in direction will be the same as change in velocity, the direction of acceleration will be the same as direction of change in velocity. Object can also move with negative acceleration when the velocity decreases with time. Then we say that the acceleration is in opposite direction to that of velocity. So that is called deceleration. So when a velocity of an object decreases with time, we say it is an example of deceleration. Here this is moving with positive acceleration. The velocity is increasing with time. So this is positive acceleration. Suppose the graph is like this. And this is velocity and this is time. So the velocity is decreasing with time. So this is an example of deceleration. Now if the graph is like this is velocity and this is time. But if the graph is like this, then it's a curved line. It's not a straight line. Here velocity is not directly proportional to time. Velocity is not constantly changing with time. So this is an example of non-uniform acceleration. Clear? Now suppose if you look at this chart, we have to define how much is the distance covered, because we know that area of this will give us distance covered. We saw it in the last graph. So distance covered will be equal to velocity into time, which is equal to, say this is, we know that the velocity is changing 10 kilometer per hour. So velocity is 10, 24 minus, sorry, velocity is changing with 8 kilometer per hour. So this is 8. Into time taken, which is 5, 50, 20 minus 15, so 40 kilometers. So between 15 to 20 hours, the distance travelled is 40 kilometers. Now, if we have to find out the distance through other method, which we said that is the area of this particular, if we find the area of this particular quadrangle. Then we can get the distance covered. So this is also equal to area of quadrangle. Now if this is A, this is B, this is C, this is D, and this line is E. This is a small triangle here. Now area of quadrangle is nothing but area of rectangle, triangle ECD plus area of rectangle ABED. Clear? Area of triangle plus area of rectangle will be the area of the quadrangle. So half area of triangle will be half base into height, which is half into phi into height, which comes out to be 8 plus area of triangle ABED, which is base into height, length into breadth, which is phi into 24. So if we calculate this, it will be 40. So a distance covered will be the area of this particular quadrangle, which is area of this triangle CED, half base into height, and area of this triangle, area of this rectangle, which is length into breadth, which is phi into 24. Moving on to our next topic. We are going to cover Newton's equations of motion. So there are three Newton's equation of motion. V is equal to u plus at, S is equal to ut plus half at square, and V square is equal to u square plus 2as. Suppose an object is moving in a straight line. Suppose this is the graph of an object. Sorry, let me plot it properly. Now suppose there is an object which is moving in a straight line with the initial velocity of u. This is velocity, and this is time. Now suppose it covers a distance of s. Between A to C, and its velocity is v. Because velocity is changing, we can say that the object is moving with uniform acceleration because it's a straight line. Velocity time graph is a straight line. Now suppose we know that acceleration is how much? Change in velocity with respect to change in time. What is velocity here? OD minus OA. OD minus OA upon time t. Why? Because you see velocity here is v. So this is nothing but if we draw a parallel line to the x-axis, we reach here at d. So velocity is OD and this is u. So this is v minus u upon t. So v minus u is equal to at, or we can say v is equal to u plus at. This is first equation of motion. So this relation, which is v is equal to u plus at, gives us the relation between time t and velocity v of an object. Let's move on to the second equation of motion, which is s is equal to ut plus half at square. Now if you look at this graph, what is the distance travelled? S is equal to distance travelled should be area of this quadrangle. We have studied this. If the movement of an object is a straight line, the area of a quadrangle of velocity time graph will give us distance. So distance is equal to area of triangle ABD plus area of rectangle EODA. Now this is how much? Area of triangle ABD is how much? Half base into height, just t time into height. Height AB is how much? AB is how much? V minus U. Plus area of triangle AODA is how much? Time into U. Now we know that V is equal to, we know V is equal to U plus AT. So V minus U upon V minus U is equal to AT. So we put this value here. So S is equal to half into AT into T plus UT. This is equal to UT plus half AT square. So this gives us a relationship between distance and time. Because uniform acceleration is A, so we say that the distance covered or displacement covered by an object and time t is given by this relation, S is equal to UT plus half AT square. Now let's move on to third equation of motion. Now distance is given by area of quadrangle ODBE. And what is the area of this quadrangle? This is the area of trapezium. The sides are parallel. ODBE. And what is the area of trapezium here? Half into sum of parallel sides into height. And what is the sum of parallel sides here? OD plus BE. Or you can say distance between the parallel sides. That will be more accurate. Half into sum of parallel sides and distance between them. Now distance between them is how much? OE. So this is half into OD, which is nothing but U plus BE. B is how much? V. And OE is how much? T. Now we know S is equal to S is equal to U plus V into T. Now what is T? We know that V is equal to U plus AT. So V minus U upon A is equal to T. So we can say like this. So we derived it from here. We know so 2S is equal to V square minus U square upon A. So V square is equal to U square plus 2AS. This is the relationship between velocity and displacement. So V square V is equal to, so we understood that V is equal to U plus AT is the first equation of motion which gives us the relationship between velocity and time. S is equal to UT plus half AT square is the second equation of motion which gives us relationship between time and distance. V square is equal to U square plus 2AS is the third equation of motion which gives us this relationship between velocity and displacement or distance. Before we proceed on further, I would like to reiterate that we spoke about uniform acceleration. These equations of motion are for uniform acceleration, that is when an object is moving with constant changing velocity with time. In the next session, we will understand the motion of an object in a circle and we will Then come back to laws of motion. Thank you. Goodbye.